So let's try a couple of harder examples. These ones involve the product rule. So, y equals x squared cos x. You'll notice I've switched notation. I actually find it easier to use the dash notation for derivatives when using the product rule. You can do it the other way, it's just more writing. Here, y is u times v, where u is x squared and v is cos x. So then u dashed is 2x and v dashed is negative sine x. So let's use the product rule. Y dashed is u, now v u dashed plus u v dashed. It doesn't matter which order you write these, but if I do it this way, it matches what happens when I use the quotient rule. Okay, carefully. V is cos x, u dashed is 2x. I might actually put the brackets in because it's going to get a bit tricky. U is x squared, v dashed is negative sine x. Simplify that, at least write it a bit neater. 2x cos x minus x squared sine x. You can factorise this. If you don't have to, it's perfectly fine to leave it there. You could take a factor of x out if you wanted to, but it wouldn't necessarily be any simpler. Let's try the next one. Y equals root x tan x. Okay, that's u v. U is x to the half and v is tan x. So u dashed is a half x to the negative a half, or maybe 1 over 2 root x. That might be easier, we'll see. And v dashed is sec squared x. Okay, so y dashed is v u dashed plus u v dashed. All right, carefully. V is tan x, u dashed is 2 root x. Yep, okay. Plus u is root x and v dashed is sec squared x. Now, you could write this as over cos squared x. It really doesn't make a lot of difference here. You could even factorise out, this is tan x, which is sine x over cos x. So there is actually a common factor of cos x over here. You could even factorise out a root x if you wanted to. That might get a bit messy.